All right, let's dive into something pretty wild. We're talking about a new frontier in cybersecurity where AI isn't just finding software bugs anymore. Nope, it's actually learning to build the perfect tools to hunt them down. This is the story of a system called ELFuzz.
So, to wrap your head around the problem, just think about the code for the Python programming language. It's huge. We're talking over 1.7 million lines. Now imagine a single critical bug hiding somewhere in that digital haystack. Finding it by hand? Forget about it. It's practically impossible. For years, we've had to rely on automated tools, but the sheer scale of modern software is pushing those tools to their absolute breaking point.
The classic automated technique is something called fuzzing, and honestly, it's a pretty straightforward brute force approach. You basically just bombard a program with massive amounts of random data. You just keep throwing stuff at it until it crashes. When it breaks, you've probably found a bug. Simple, right?
Well, here's the catch. For really complex software, think a database or your web browser, the inputs can't just be random noise. They have to follow super specific rules. So just throwing random data at them is like trying to find a specific keyhole in a pitch-black room by just randomly chucking keys at the wall. Most of them are just going to bounce off, never even getting close to the deep, tricky parts of the code where the really nasty bugs love to hide. To get around this, developers have had to build these incredibly specialized, handcrafted fuzzers that actually understand the rules. But the effort, it's just immense. This number right here, 80,000, that's how many lines of code it took to write CSmith, a famous fuzzer for the C programming language. Manually building a custom tool this complicated for every single piece of software out there, it just doesn't scale.
So, to sum it all up, our traditional bug hunting tools are basically hitting a wall. They can't scale, they're slow, they're inefficient, and you need a ton of human expertise to make them work for different programs. This is the exact problem that the creators of ELFuzz decided to tackle.
And this is where a completely new way of thinking comes into play. Instead of a human spending months or even years writing a perfect fuzzer, what if an AI could just build one for us? This, my friends, is ELFuzz. The researchers themselves put it perfectly in their paper. See, ELFuzz doesn't just use an AI to generate inputs. No, it uses a large language model to automatically build the fuzzer itself through a process that's inspired by evolution.
And this right here is the major shift in thinking. It's a game changer. We're moving from using AI as just another tool in the toolbox to using AI as a master tool builder. It's a meta-level solution. Teach the AI to create the program that will then go find the bugs. So how does it actually do it?
So how does this whole learning thing work? Well, ELFuzz works by basically mimicking natural selection, Darwin style. It starts with a bunch of really basic, honestly pretty terrible fuzzing programs, and then evolves them, generation by generation, into these highly effective specialized bug hunting machines.
It's this simple, elegant, three-step loop. First, the AI acts like the engine of mutation, making intelligent changes to the fuzzer's code. Second, these new mutant fuzzers are unleashed on the target software to see how well they do, specifically how much of the code they can reach. And finally, in classic survival of the fittest style, only the best performers are chosen to survive and breed the next generation.
And the way the AI mutates the code is just incredibly clever. It's not random at all. It's designed to mimic how a human programmer would actually work. You've got splicing, which is like genetic crossover. It takes two successful fuzzers and combines their best DNA to make a new one. Then there's completion, which is like the AI finishing your sentence, taking a partial idea and intelligently building it out. And infilling is like targeted surgery, where the AI zooms in on one little piece of code and reworks it to make it better.
But wait, how does it know what better even means? This is the secret sauce. It's a concept they call fuzzer space. The best way to think about it is like a GPS for the AI. Instead of just wandering around randomly, it tracks the exact territory each fuzzer has explored. This guides the whole evolution process, pushing the AI to create fuzzers that find brand new, undiscovered paths, not just walking over the same old ground.
Okay, so the theory is fantastic. It sounds amazing, but does this AI-driven evolution thing actually work in the real world? Well, the researchers put ELFuzz head-to-head against the current best tools out there.
The first big test is code coverage, which is basically just a measure of how much of a program's code a fuzzer can actually test. And let me tell you, it wasn't even close. The fuzzers built by ELFuzz were able to dig way deeper into the target software than anything that came before. How much deeper? Try this number on for size. ELFuzz achieved up to 418.5% more code coverage. That is not a small improvement. That is an absolute staggering leap forward. It just proves that it's building much more sophisticated and effective tests.
Of course, coverage is great, but it's just a means to an end, right? The real goal is to actually find bugs. So, the researchers tested the tools against software where they had hidden thousands of known bugs. And, yep, you guessed it, ELFuzz came out on top again, finding way more bugs way faster.
But here's the ultimate test. The real holy grail of security research is finding bugs that nobody knows about. These are called zero-day vulnerabilities. And in a single 14-day campaign, ELFuzz found 5 of them. 5 brand new, undiscovered bugs in a modern, widely used program.
And these weren't just minor little glitches either. We are talking about serious, exploitable vulnerabilities. A format string injection that could let an attacker run their own code. Denial of service bugs that can crash critical systems. And bugs with invalid pointers that could be used to hijack a program completely. This is real-world impact.
Okay, so let's pull back and look at the big picture. What does all of this really mean for the future of software and security?
The most important takeaway here is that this isn't just some cool academic project. A tool that can automatically find deep hidden bugs better than we ever could before makes the software we all rely on every single day safer. We're talking about everything from your banking app to the power grid. Ultimately, the thing you should really walk away with is this profound change in how we think about AI. ELFuzz proves that the next generation of AI won't just perform tasks for us. It's going to start building the custom, specialized tools we need to solve our most complex problems.
And this all leaves us with one final, fascinating, and kind of mind-bending question. We've just seen an AI that can evolve expert bug finders from scratch. So what's the next logical step? An AI that doesn't even need bug finders because it's learned how to write secure, correct code from the very beginning. And a world like that, well, that could change absolutely everything.